Welcome to Chapter 8, Metamorphic Rocks, beginning on page 98. So on page 98 through 100, I want you to explain how metamorphic rocks are classified and identified. There are two things that we use to identify them. What makes a rock metamorphic and no longer igneous or sedimentary? So tell me what has happened to it for this change in this alteration. Explain the difference between a foliated and a non-foliated metamorphic rock, and then then tell me why are some rocks foliated and others are not. So what is the underlying reason why you would get a foliated versus a non-foliated rock? Hint, it has something to do with the mineral shape, and we talked about this in class. Okay, so that's on page 100 and page 98 through 100. Okay, so it shows you foliated rock, non-foliated rock. So tell me how these two rocks form. On page 101, I want you to create a legend for this diagram. So explain how a gneissic texture develops in words based on the picture. So using your own words, describe what's happening here. On page 102, explain how we classify metamorphic rocks. What are the categories they fall into? What are the features you look for? Those are the types of things you should include. Okay, page 103 shows you a PT, pressure temperature diagram of metamorphism. So there are different types of metamorphism. There's contact, hydrothermal, regional, and subduction zone. There's also one that's not included in here, which is my favorite one. It's called shock metamorphism, and that occurs very rarely when a meteorite impacts rock on Earth. It shocks it into metamorphosing. That's pretty cool. Okay, so on page 103 to 104, which shows you metamorphic grade and the environmental setting for different metamorphic grades. Explain what the different categories are and what they're function of. What is metamorphic grade? And explain the differences in the types of metamorphism using this diagram from page 103. Okay, page 105. Create a legend on this page which explains the types of metamorphic environments as well as the PT conditions under which each grade of metamorphism pictured would occur. So what are the PT conditions for high grade? Hint, high grade means high pressure, high temperature. Partial melting, here you could think of this as contact metamorphism, so it's probably going to be a low temperature, high pressure, since it's underneath the surface. And then here would be low temperature, low pressure. All right, that concludes chapter 8.